Okay, here's a quick DSP short video about 2's complement conversion. We talked about this when we did the successive approximation A to D conversion. For me, it's turned out that I've had to do 2's complement conversions enough times in my career, mainly through teaching, but also with some audiology kind of projects that I used to work on. I've had to do it so many times that you start looking for a shortcut way of doing 2's complement. All right, and so one way to think of 2's complement, and this is useful, think of it as a scaling problem where you're trying to go from a number x, all right, and let's say this number x, let me redraw this, this number x is positive, okay, so here's 0, this is r over 2, this is minus r over 2, and the number x falls somewhere in the total range r. Alright, well, with 2's complement, you're simply scaling everything. Okay, so for the positive numbers, you're scaling everything to go between 0 and 2 to the, if you have b bits, you allocate 1, the number of bits that you use in 2's complement is b. You use b minus 1 to the b minus 1, and then just because you don't have enough bits, you have to subtract 1 for this upper limit. And then for the negative numbers, we'll talk about those in a second, the scale goes 2 to the b minus 1 without the subtraction of 1. Okay, so you end up taking this scaling, moving it over to a different scale. All right, so long story short, the way you make this conversion is you take the number x, you divide by the range, and then you scale by 2 to the b minus 1 minus 1. That gives you a new number, and then you simply round that off. And from there, if you convert that to hex, it's easy to go from hex to bits, and you get the 2's complement conversion for a positive number. Okay, so that being said, what about negative numbers? Well, negative numbers simply have subtraction already built into them. All right, so if the number is negative, what you do is you take 2 to the b, and then you add in the same kind of scaling. So x is a negative number, so this would be actually a subtraction here. So 2 to the b plus a negative x, you scale that by r, and you multiply that by 2 to the b minus 1. Okay, when you do that addition, you get a number, and then you simply round that off. All right, so there's two different cases, one when x is positive, one when x is negative. All right, so you can try that on your own. I've given some examples. I wrote some MATLAB code. If you look here, here's the MATLAB code. I'm taking a look at an input vector x. I have a scale r and a number of bits in the 2's complement representation denoted by b. All right, so the code here is, first of all, it only works for scalars. You take the decimal to hex conversion, rounding x scaled by r, and then multiplied by 2 to the b minus 1. And I actually forgot the minus 1 in this code snippet. I went back and put that into the actual code so it runs correctly. So if you look on my MATLAB, you can actually see some examples of this code running. Okay, this was actually a homework problem. You take, or an example problem from the book, you take 3.5, the range is 10. Okay, so you take 3.5 and you divide by r, divide by the total range, r, and you scale that by 2 to the 3rd minus 1. All right, when you do that and do the conversion, you get the hex digit 3, which is 110, but remember it's 4 bits, so there's a 0 out front. We knew that because it's 2's complement. That's a positive number, and so that should have 0 in the most significant bit position. Okay, so try a few of those. It's really pretty easy once you get the hang of it. Okay, So let's do this one. This would be 3.5. You divide by r, you multiply by 2 to the 15th minus 1. You round that, and then you convert that to hex. When you do that, you get 2ccd, and it's pretty straightforward to convert all those to bits. All right, so the last thing is a negative number. How do you handle a negative number? So remember, if it's negative, you have to add 2 to the b. All right, so this is 5, so I take 2 to the 5th plus the negative number x scaled by r multiplied by 2 to the b minus 1. You take that number, you round it, so r for round, and then you convert to hex, and you get 1e. All right, so think about what 1e is in bits. We have the 1, and then we have 1110, so that's the 5-bit representation of minus 1.5. Okay, so easy enough to do. Want you to know how to do it. Might ask it on an exam question. Who knows?